Okay, so could you maybe take just a moment, reread the problem number 1 on that 5-6 differential equations in a context worksheet, and just look back through what we did in ABC, just to jog your memory so we're not totally starting from nothing. And let's get Chromebooks away and all that stuff, because we shouldn't need them anymore. Okay, so again, you're reading number 1. Just remind yourself what's going on in the problem and what we've already done. So we had a differential equation that gave us the rate of change of the height of the tree. Not the height, but the rate of change of the height. I compared rates of change of the height in part A by just plugging into that differential equation, because that gave me dHdt, the rate of change of the height. Part B, we found our second derivative. We got it just in terms of h by replacing dHdt with what we knew it initially was. And I was able to use some logic to say that the second derivative is always negative because the height has to be less than 10. So that second derivative is negative, which means I'm always concave down. Part C, we did our tangent line approximation. I didn't really like x's and y's, so I changed it to the variables that were used in the problem. Got things there, and we talked through the overestimate because of our concavity, going back to our linearization stuff. Part D. We are asked to find the particular solution to the differential equation when h of 0 equals 1, which means by the time we're done, we're going to have a function that actually gives us the height of the tree. Not part C. Part C was an approximation. Part D will actually be the function that gives us the height at any particular time. We have the differential equation dHdt equals 3 over 20 times 10 minus h. The method we're going to use to solve this is separation of variables. Exactly. What do you want to do? Yeah, and I suppose we could move the fraction with the 10 minus h, but it's not going to be pretty to do it like that. So why don't we say dh over 10 minus h equals 3 over 20 dt. No, it won't be. Because then you're going to get dh over 30, 20. No, you're going to, no, I'm just going to leave it at that. How do you integrate the left side? Not yet. What? Not yet. Use substitution first. And as opposed to other problems where you can kind of get away without it, although we shouldn't, here it's definitely going to make a difference. What's u? 10 minus h. So what's du? Do you see why that's pretty important? We've got to get that negative in there. Negative dh. So how about you keep going now with the left side. Question, Paris? We're allowed to use natural logs when the denominator is a single variable. This is more complicated than a single variable, plus the derivative of that is negative dh, which means we've got to do our adjusting and all that. See if you can integrate both sides and then stop and we'll do the algebra together, although the algebra won't be a big deal. Because we know that h is always less than 10, I guess not. I'm going to drop them later when the math works out, but no, I guess not. But can you get something like that? I feel like you also can probably handle solving for t. It's a little different than other things we've looked at, but not anything too bad. Divide both sides by -1, do your e raised to the, right? You're going to get the plus c in the power, so you can move things. See if you can handle the rest of this. Do your solving, and when you've solved for h, sorry, I think I said solve for t, I didn't mean that, I meant solve for h. When you're done, deal with your initial condition as well. At time 0, the height of the tree is 1. And if you do need to check in with someone near you, you're welcome to do that. Order. Actually, I don't know why I just did that.
Can you say plus?
I did.
No, that's what I'm asking.
Can you?
Why can you do that?
What's a constant times -1? A constant.
I guess. So would it be wrong if you said minus?
No, because it's all going to get taken care of in the end anyhow when you plug in your initial condition. So it's not going to matter. What's a constant times what's a constant times 2? It's still just a what's a constant times 10? Still a constant. What's a constant times -1? Still just a constant. If you don't like this, leave it as -c, and it will get taken care of when you do your initial conditions. It's not going to matter. Were you able, though, to move the c out front because we saw the plus c in the power and all that? We've seen so many of those by now. Well, that's kind of nice, I guess. I think. C is -9. Unless you put a -c in the problem and then c will be +9. That's why I said kept saying it doesn't really matter what you do. I'm going to get 10 minus 9 e to the -3 over 20 times t. No? What's wrong? No. So I've got 3 over 20t, but then before I did my e raised to both sides, I had to divide both sides by -1. You do because the e gets rid of a natural log, not a negative natural log of something. I guess you could have made the -1 into a power, but that's going to make it even uglier. So yeah, you've got to divide both sides by -1. Anything else? What did I just find? Not the rate of change of the height, but an actual function that will tell you the height at any particular time. With that in mind, do part E without a calculator, which means you're not going to get a decimal answer, you're going to get an answer with some natural logs in it. Can I assume you're plugging in h where the h is, not where the t is? Good. And then it really is just algebra to finish this. Well, hold on. Yes. Can you get something like that? -20 natural log 2/9. It is still a positive time because the natural log of 2/9 is negative, so that times negative will make it positive. Plus, I knew that, like, physically, it's got to equal 8 feet at some point, because I know it's going to reach 10 feet, and I know I'm starting at 1 feet. So actually, by what theorem? By what theorem can I prove it's going to be 8 feet somewhere?
The highway camera theorem.
I think I need to start putting this on cumulative reviews again. Intermediate value theorem, yeah. Don't worry about that. I'll take care of that. Questions on these things? Because I feel like in the homework, you're going to see variations like these. Although part D, absolutely every problem in the homework will have a part where you have to actually solve the differential equation and go from there. Okay. Turn the page, read the next problem, which did actually come from an old AP exam, and that will be our second example. A few other variations in this one. Probably because they're trying to test you on the calculus, and you can't do anything with this if you don't have that formula, even if you know calculus. So they probably would. If it was a cone, absolutely they would, or a sphere. Did you sign out? How about you sign out on your Chromebook? Because that's like why we have them and things. Okay, so you read? We've got a differential equation that relates the rate of change of the height to the height. It's not proportional to the height, it's proportional to the square root of the height. Okay, whatever. Find the rate of change of the volume of the water in the barrel with respect to time when the height of the water is 4 feet. Say that louder in the back. Oh, this has nothing at the moment, not really, to do with differential equations. We'll get there in a little bit, but this is a related rates problem. I know, okay, part 1, I know that the volume is pi r squared h. You know what I think I should also start putting on some more cumulative reviews? It's been a little while. I need you to go back and review some of that stuff. Part 1 is where we tell anything that's always true. Is anything always true for this cylinder? What was that? Diameter is 2, which means radius is always 1. Not true if it was a cone, but in any sort of cylinder, you drain the cylinder, you're not changing the radius. So that is something I'm going to fill in. V equals pi h. That is kind of nice. What am I looking for? I want to find dv dt. What was that? Well, v prime, but I'm going to call it dv dt. When? When h is 1. That's what I now have written. I hope like this structure looks vaguely familiar. Yeah, I know I need to start throwing some of these on there. Do the derivative of the left. What's the derivative of v? dv dt. What's the derivative of the right side? Pi dh dt. Hold on. Hello? Hi. We'll see. How are you? Yes. He's not using his Chromebook right now. Srihari, do you have a Chromebook with you? Yes. No. Okay, read the numbers off the back of the Chromebook you have. Oh. Change of plans. He doesn't have his Chromebook. He's trying to figure out where his Chromebook is now. He's thinking. It should be in Spanish? Oh, dear Lord.
I don't know.
Oh. That makes more sense to you than anything else. Okay. Oh, it's been in Miss Wolf's room for a long time. No. Wait. Okay. So someone else brought down his Chromebook thinking it was hers and said it was hers, but it's really his, and it's now in the office. Okay, after class, Srihari, get your Chromebook from the office. And maybe ask Mrs. Cheney to tell you a good story, because she's got a good story. Thank you. Bye. Okay. That was fun. And I'm still recording. Wonderful. Okay. I've got a problem now, because I need to plug things in, but I don't... we have a formula for Dht. We know dVdt equals pi times negative 1/10 times the square root of h. Go finish the problem off. Finish it off, give me an answer, and make sure you're putting appropriate units on that thing. And you know what, just so like these notes may be helpful later, I think I'm going to write a little comment next to this. What is A all about? It is related rates. They can include related rates with these differential equations because there's dTs and all that stuff. So dV dt equals, I'm just going to say negative pi over 10 times square root of 4, negative pi over 5. What are the units? Feet cubed per second. So I'm finding the derivative of my volume formula over there, like the related rates ideas. Because R is a constant, the radius of the cylinder of water is always 1. Is it okay that it's negative? Of course. What's the rate of change? Well, the rate of change is some negative number. Okay, next. Really? When the height of the water is 3 feet, is the rate of change of the height of the water with respect to time increasing or decreasing? Did I just ask you, is the height of the water increasing or decreasing?
No, the rate of change.
Oh. What? Say that again? Aha. I'm actually asking you about the second derivative. So, again, the height of the water, that's always decreasing. We know that. I'm asking, is the rate of change of the height of the water? We know that that's some sort of negative number. Is that rate increasing or decreasing? So, I feel like this gets complicated, and I feel like 2 years ago I got the perfect example to talk about this stuff. April of 2020, I got the perfect example to talk about this. That was back when every day at 11 o'clock in the morning, when I wasn't teaching, I would watch the news conference from New York with the governor who would give the daily COVID. Remember, we'd always say today is Monday or something like that. And at some point in April, he said, well, so I've got some good news. The number of cases of COVID in New York is still rising, but it's rising at a decreasing rate. They were still going up, but they were not going up as quickly as they were the previous day. What was that? I may have told you this with some other case, but I feel like that's going to come back with our Part B, and I'm going to tell you that story again when we get into our next unit. That's kind of what we're talking about here. We're talking about the second derivative. I want to know, sure, the cases are going up. I don't care about that. But the rate of change of the cases, well, they were increasing for a while. Still going up, but the rate of change of the cases is now decreasing. No, that's not what I meant. Yes, that is what I meant. The cases are still going up. The rate of change of the cases, that was increasing, which was when things were bad. Now it is decreasing, which means the cases are still going up, but at a smaller rate. Kind of like they're increasing not as fast, but still increasing. That's what I'm looking for here. How do you figure out if anything is increasing or decreasing? You look at its derivative. Well, what's the derivative of the rate of change of the height? The second derivative. I need to find the derivative. Hold on. Of dH dt. Which, yes, means I need d squared h. Forget this. Let me go back to my regular notation. I'm finding the derivative of dH dt. I'm finding the derivative of the other side. Maybe you don't need this first line. Whatever. What's the derivative of dH dt? It's d squared h dt squared. As for the right side, do your derivative. Of course, square root of h is h to the 1/2. see, so negative 1/20th, h to the negative 1/2.
Yep, so negative 1 over.
You
But you have to
gotta,
multiply by DH.
Thank you, dH/dt. Why? Because everything's a function of time here.
yeah, what's
Ah.
3 at?
Because I had negative 1/10, whoa. I feel like you're mixing up derivatives and integrals. Pull down the power, subtract 1 from the power. So negative 1/10 times 1/2. Subtract 1 from the power, you get negative 1/2 there. I don't want to leave dH/dt in here.
So you know DHDT.
This is the same trick we saw in that first problem. Why don't we say d squared h dt squared equals negative 1/20th, h to the negative 1/2. Maybe I should have already moved that. Say that again? No. Because I've got an h to the negative 1. I take that back.
They cancel.
I take that back. Yes, you're right.
Right, you make me look stupid.
I do that sometimes. Yeah. Okay. So make me look stupid and tell me what the constant is.
Oh, negative 1 over 200.
1 over 200.
Attaboy.
Which means, actually, the rate of change of the height is always the same thing, which kind of makes sense. It's a cylinder, so it should be changing. Whatever. When the height is 3 feet, is the rate of change of the height increasing or decreasing? What I'm going to say is because d squared h dt squared, when h equals 3, explain your reasoning, yeah, that's justifying. So, feet per second, divide by another seconds. So feet per second, or like using an acceleration idea, which I don't really want to say, but it's kind of a similar idea. It's like feet per second squared. It's really like feet per second, though, per second. Because that's positive, the rate of change of the height, the rate of change of the height of the water is increasing. Because the derivative of the rate of change of the height was something positive. And that's usually going to be our interpretation of a second derivative of these things. Is the rate of change itself increasing or decreasing? I don't think I have anything new to teach you about part C, so go do it. These questions will always involve a part that says solve the differential equation. So solve it, please. Unless I have to say anything else about B. Because my function actually had no place to plug in the 3. If there was an h in the final formula, then I absolutely would have plugged it in. But I'm kind of saying, you plug in 3, you plug in 5, you plug in 1, you plug in anything, you're always going to get that 1 over 200. Okay, so dH dt equals negative 1/10 root h. I hope we've got dH over root h equals negative 1/10 dt. Natural logs?
No.
Thank you. Just normal power rule. So keep going. Keep going. Go solve for h, deal with your initial condition. Question?
No.
I actually think this is kind of similar to one problem that we looked at with the raffle. How are you going to undo your square root? Yeah, not square root, but squaring both sides. And remember, we've got to square the entire side with the plus c inside there. Maybe? To square that side, I would have to like FOIL and stuff, and I'd get a t squared and a constant times t and something else. You can't say this squared plus that squared. Whoa, whoa, whoa. If I gave you x plus 3 squared, that's not x squared plus 9, right? For the same logic, I can't distribute the square over here. 5 equals 0 plus c squared. C is root 5. Yeah. Okay, you don't have to like it, but it is right. And as opposed to my fractions inside fractions that I'm not okay with, square roots inside things are just fine. Questions? James, you look like you've got a question. You sure? Anyone? We don't have time to do all of 3, but I think we need to look at A and B, and part C is another, just solve the differential equation I think you can handle. And you know what? Maybe A you can handle too. So how about you read 3, read A, and see what you can do. The equation's a tiny bit different than the other ones, but I think we can do some stuff. Y minus y1 equals m times x minus x1 initially. Yeah, let's use f's and t's. So f is like the y. T minus t1, okay. Whoa, 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 whoa. No, this is like problem C from the first question we looked at. And also kind of like that AP free response we did in class. They want separation variables much later in the problem. We don't need any of that to get our tangent line. Do you have T1? What is it? 1. Do you know F at T1? How did you know that? They told you. Do you see where I'm getting that from, Ferris? Then, how am I going to get my M? Plug into your df dt. You're going to plug in your t equals 1 and f equals 32, although I think the f's not going to matter. The t is the one that's going to matter there. So 48 over the square root of 3 times 1 plus 1. 48 over square root of 4, 48 over 2, maybe 24. I would, but because we're going to do a linearization thing, I think we should solve for f, which just means move the 32 over, but not distribute or anything. So I've got a tangent line. Now what? Plug in your 2. So go do that. Find f of 2. Sorry, this isn't really f of 2, but it's our approximation for f of 2. Whatever, I'm just going to call it f of 2. And here's where I kind of think leaving it in point slope form makes it a little bit nicer. I think. What was that? 56 orders. This is not saying that at time 2, they're getting exactly 56 orders. The only way we can find that for real is to actually get a function for f, not a tangent line approximation. But it's a good approximation and took less work probably than separation of variables, which is what part C would ask anyhow. Anything here? How about you read B? See if you can do B. Maybe don't worry about the explain and the context part. We'll handle that part together, but I think you can go through the calculations at least of finding f double prime of 5. And we've got df dt equals 48 over square root of 3t plus 1, which actually I'm going to say is 48 times 3t plus 1 to the negative 1/2. Find your second derivative, and we'll deal with the ending part together. And maybe we even will get to part C. Remember, it's a derivative, not an integral. Pull down the power, subtract 1 instead of add 1, divide.
And chain rule. The chain rule is
There is chain rule in here. Yeah, chain rule rather than use substitution. Three df dt. 3 df dt. Or just 3. I am taking the derivative of t. This is different than the other problems where I had like an f in the problem, and what's the derivative of f because it's a function of time? df dt. Here, my variable is t, the independent variable. So what's the derivative of t? Just 1. So I'm just going to say times 3 at the end. So maybe negative 24 times 3, maybe negative 72 over 3t plus 1 to the 3 halves. Find your second derivative when t equals 5 without a calculator. Um, 16 to the 3 halves, you're not using a calculator. What are... Yeah, do your square root first. Don't do your... Wait, hold on. You didn't mean 4 squared. You meant 4.
I said just turn 16 into 4 squared and then multiply the...
Yeah, that works. Or, like, think about it as do your roots, then do your power. Square root of 16 is 4. Cube gives you 64. Don't do your powers first. Do your root first. Simplify that. Negative 9/8. Let's start our interpretation, and then we'll get those units in there.
orders per hour squared.
No, yeah.
Okay, so fine. We'll deal with that now. F is orders. df dt is orders per hour. So the derivative, let's divide by another, is orders per hour, or orders per hour squared. But that is not good enough for our interpretation. I feel like something we already did today is the... So what's happening?
Every hour, like, it's decreasing. The rate of change is decreasing.
Okay, we're talking about the rate of change of the number of orders. So first of all, when we interpret things, we've got to make sure we refer to the fact that I plugged in a 5. What does the 5 mean? At t equals 5. At t equals 5, what? The rate of change of the number of orders is increasing or decreasing? Is decreasing at a rate of 9/8. So I'm kind of glad that you didn't say negative because we included that with our decreasing part. 9/8 orders per hour squared. Again, I'm not talking about are the orders increasing or decreasing, but the rate that orders are coming in, that rate itself is decreasing. I want to just start part C. There's one little weird part in the beginning. Maybe not weird, but I just want to make sure you see that. Then the rest of it I think you can absolutely handle on your own. Find an expression for f of t. Oh, you know what? I guess they didn't say how to do it. Oh, but I think we should probably do our separation of variables. And actually, how? What? How about I just put the dt on this side and say I'm separated? And honestly, this is kind of like one of those original differential equations we could actually just solve by integration but I don't even care about that. We'll separate. How about we say, 48, 3t plus 1 to the negative 1/2 dt. The 48, I'm just going to move outside my integral because I can. A dt, say what you just said again. You need a u substitution to integrate that because there's something inside your integral. You see that? Do your integration. See how far you can get with this. While you're doing this, I'm going to get out the homework and the cumulative review. The two weird parts with this one that I wanted you to see was the t's rather than f's, and we're going to have to do u substitution. The rest I think is pretty straightforward, but see how far you can get with that. Do the work on a separate sheet for the homework. There is not enough room to do it well on it. There are two multiple choice things. What if I get them to firework? The back, sure, then you're going to be flipping back and forth, but you can do that to save paper. Don't cram the work in where the problems are. Try hard. Yeah, I should.
Well, I do homework.
Yeah. You're also a little annoying sometimes. We're integrating, I hope. Oh, and then Monday, it gets good. Yeah, I love Fields Monday. We're going to draw crazy pictures on Monday. Yes, yes. Of course, we haven't learned how to do it. Come back on Monday. It'll make sense.
Wait.
That's the homework.
Oh!
I have a question.
Oh, whoa. Okay, you gotta find your constant. Did I give you any initial condition in part C? No. Did I tell you it's somewhere else in the problem? Aha. Going back to the beginning, I think it told you that f of 1 that's the initial condition, which may not always be given right in that part, but may be given in the initial setup to the problem. So I'm doing 3t plus 1, du is 3 dt. 3 in, a third out. F is 16 times the integral of u to the negative 1/2 du. I hope this is a little like your work, maybe. Oh, goodness.
Please excuse the interruption. At the bell, would all students who are participating in the at-home answering test please come to the front office to pick up the test.
Do you have f is the 32 times the square root of 3t plus 1 plus c? So again, the initial condition we're going to use was not from this problem, but was from the original that told you at time 1 there were 32 orders. You'll use that to find your c. When you're done, you'll do your f of 8. That's what's going on here. So even if we don't finish, you got a sense where this is going. Oh, this is going to be really nice. 32 equals 32 times something. It's negative 32? Why negative? Oh, yes. Wait, I don't know. No, you can't do you can't do that because of the c. Yeah, c is negative 32. Do you have negative 32? Yes, we're fine. What was that?
2 divided by 32.
Yeah, you can't because of the constant. Because once we start solving for the constant it plugged in, we can't do that.
3t plus 1.
3t plus 1 minus 32 at the end. Yes. Then we'll just find f of 8.
F of 8 would be 32.
That's a 5. Go to the office. Mrs. Cheney will tell you a good story. Someone else took your laptop and said it was theirs, and she said, no, it's not. This number belongs to Sri Hari. Just get the computer from her. I'm getting 128 orders if anyone was still finishing. What?
Yeah, just 32 times 4.
What's English?
I think second now.
Oh, man.
32 times 5. Well, yeah, oh, fine. Yes, fine.
What was that?
That will work. Okay.